This work investigates the potential impact of deep generative models on the work of creative professionals, specifically focusing on fashion design. We argue that current generative modeling tools lack critical features that would make them useful for creativity support. We introduce our own tool, generative.fashion, which was designed with theoretical principles of design space exploration in mind. We conducted 2 qualitative studies with fashion design apprentices to evaluate the effectiveness of generative.fashion and compared it with a state-of-the-art diffusion model, Stable Diffusion. We distilled our findings into 3 insights related to the use of deep generative models for creativity support. Our first insight, Principle 1, suggests that exposure to unexpected regions of the design space supports divergent ideation. Text prompts may not be suitable for this task, since it's difficult for a user to describe a design that they're not expecting to find. Instead, users should be provided with ways of rapidly generating multiple outputs from a large volume of the design space. We found providing the ability to randomly sample points from larger or smaller volumes of the GAN latent space best supported the start of the divergent thinking process. Our second insight, Principle 2, suggests that control over model stochasticity supports the transition from divergent to convergent ideation. After identifying promising regions in the design space for further exploration, users should be able to set constraints on model stochasticity that support intentional and meaningful exploration of those regions. In generative.fashion, 2 features provided this ability. The style mixing panel made it possible to navigate between different regions of the design space. The design canvas provided the ability to navigate within a region of the design space by choosing meaningful directions to explore. By using an intuitive drag-and-drop interface, apprentices were able to control the size of steps that they took in any of these directions. Our third insight is that high-quality, precise model outputs are useful during the final phase of the convergent thinking process. In contrast to our tool, generative.fashion, Stable Diffusion produced clearer, higher-resolution images, and when provided with detailed prompts, it produced designs with more accurate details and styles. These findings provide support for our hypothesis that unlocking the potential of deep generative models for creativity support depends on the development of interfaces and functionalities that are specifically designed to support design space exploration. We hope to bring attention to our theorized connection between the learned latent space of deep generative models and the design space of a domain, and view the development of tools grounded in this theory as a promising area for future research on creativity support tools and design space exploration.